Hello everyone, today we have s plus 8 in bracket to the power of 2 all equals to 64. So we're going to solve together. Let's start by saying solution. In solving this, we'll use two methods. The first method is the difference of squares, while the second method will be sum of two squares. So if we start by saying method 1, so that s plus 8 to the power of 2 equals to 64. But we can write x plus 8 to the power of 2 minus 64 equals to 0, and it's fine. But 64 is same thing as 8 to the power of 2, and our equation becomes s plus 8 to the power of 2 minus 8 to the power of 2 all equal to 0. But from algebra, we have a to the power of 2 minus b to the power of 2, which is represented as a minus b times a plus b. Here, a is equal to x plus 8 and b is equal to 8. So the next line becomes x plus 8 minus 8 plus the bracket x plus 8 plus 8. This is x all equal to 0. 8 would cancel out, plus 8 minus 8 will be equal to 0. What is left here is x into x, 8 plus 8, x plus 16, all equal to 0. So this gives us two cases, and the first case, s is equal to 0, or x plus 16 is equal to 0. So if you do this very one, s will be equal to minus 16, and s, of course, is equal to 0. And method 2, we're going to write as x plus 8 to the power of 2 is equal to 64. But a plus b to the power of 2 is equals to a to the power of 2 plus b to the power of 2 plus 2ab. So this part is in the form of this, where a is equal to x and b is 8. So if we agree on this, our equation therefore will become x to the power of 2 plus a to the power of 2 for this, plus 2 times a is x times b is 8, which is equal to 64. And if we simplify further, we have x to the power of 2 plus 8 to the power of 2 plus 2 times s times 8, that is 16s, all equal to 64. And s to the power of 2 plus, but 8 to the power of 2 is the same as 64 plus 16s equal to 64. We want to bring this 64 to this left hand side. It becomes s to the power of 2 plus here 16s plus 64 minus 64 all equal to 0, and we are fine. So if you do this very one, we're going to have plus 64 and minus 64 cancelled out. What is left is s to the power of 2 plus 16s equal to 0. And this is written as x times x plus 16 times s equal to 0. So what is common here is s. So if you factor out this s, write out s. So s times s divided by s to be left with s plus 16 times s divided by s, that is 16, equal to 0. So here, either s is equal to 0 or s plus 16 is equal to 0. Of course, here s is equal to 0 and s is equal to minus 16. And this is the second value for the second method. So in the first method, we had s equals to 0 and s equals to minus 16. And also in the second method, s is equal to 0 and s equals to minus 16. We want to check if actually the value for s satisfy the original equation. That is, to verify our original equation, x plus a to the power of 2 equals to 64. For s equals to 0, s plus 8 to the power of 2 equals to 64. So in place of s, we are going to write 0 plus 8 to the power of 2. Could it be equals to 64? Here, 0 plus 8, that is 8, and 8 to the power of 2, can this also be equal to 64? And we know 8 to the power of 2 is 64 equal to 64. That means the value of s as equal to 0 is true. And for the second value of s, which is for s equals to minus 16, x plus 8 to the power of 2 equal to 64. So minus 16 plus 8 to the power of 2, can it be equal to 64? And like we know, minus 16 plus 8, that is minus 8 to the power of 2, can this be equal to 64? And minus 8 to the power of 2, it's 64, which is equal to 64. This is also true for s equals to minus 6. That is to say, the two methods gave us the same values, and they all both satisfy the equation. Thank you for staying tuned. I hope you look forward to my next video. Bye bye.